It's machine learning and deep learning. Maybe this area is rare for you. You might have gone other domains, and this is a core subject for any branch. There is no barrier for civil, mechanical, electrical, computer science. Anybody can learn data science. If you know 6th class to 10th class mathematics, you are eligible to learn data science subject. Very simple. I'll explore my knowledge in this domain. I started with data, information, database, data warehouse, data mining, then come to the data science. In between, we have a umbrella like artificial intelligence having its own branches like machine learning, deep learning, statistics, neural networks, various subjects are involved. Let me justify my title first. What is data science? Data science is the process of extracting meaningful, interested patterns from the huge volume of data by applying statistical techniques, machine learning techniques, deep learning techniques, and various tools and frameworks. Especially applications like a healthcare domain, traffic data analysis, weather forecasting, e-commerce, stock market exchange, whatnot. Wherever data is presented, we can apply data science tools and techniques in order to find out and extract insights from various volumes of data so that we can increase our business in various domains. Then by using artificial intelligence, there are various techniques. Intelligent behavior in a machine is called is a robot, best example. There are various humanoid robots are available, like Asimo, Sophia. Sophia recently took the citizenship of Saudi Arabia. She can dance, she can do many things. With the help of expert system built, if then rules, how we have developed instructions. Then machine learning from the observational data by using supervised learning, unsupervised learning, and reinforcement learning. These are the three techniques we are using in order to extract meaningful, interested patterns from the huge volume of data. And third technique is deep learning. It is extension of machine learning. In machine learning, three approaches we are using. Supervised learning, that means there is a target class. Based on the label, we are classifying the data. By using supervised learning techniques like support vector machine, random forest, Bayesian networks, various supervised learning techniques we are applying. Unsupervised learning is nothing but I don't know label, I don't know what type of data is presented, but I would like to classify the data based on the similarity measure. How do we calculate a similarity measure? By using Euclidean distance. We have 2 points like x1, x2, y1, y2. Square root of x1 minus x2 whole square plus y1 minus y2 whole square. Based on this formula, we are calculating Euclidean distance to find the distance between one point to another point. So that based on similarity measure, we are making a data into clusters. That is called unsupervised learning. There are various techniques like K-means clustering, C-means clustering, and density-based clustering. Various clustering techniques are available. And reinforcement learning techniques is nothing but based on the punishment and reward, we are solving the problems, especially gaming applications. There are various algorithms are presented in the reinforcement learning. I'm going to demonstrate with practicals on various data sets. If you provide any data set, I can do classification, clustering, and association tool mining, outlier detection, what kind of data analysis user requirement I can do with help of Python programming. So that is justification of my title. So Ayanka, she explained my background, and these are my interest domains like data science, artificial intelligence, machine learning, deep learning, cyber security, and thanks to Ravi sir, he has given opportunity to learn new subjects like water quality and pollution control, environmental science and chemistry, environmental monitoring and remediation technologies. These are my publications are available in IEEE Explore and Science Citation Index, Web of Science, and Scopus. And if you are having a mobile, you can check my videos, 250 videos all over the world. I have explained 175 webinars I have conducted last 3 years. So I haven't prepared for YouTube channel, but all that videos I kept in that folder, not for money. My students, my scholars may visit my YouTube channel so that they can get knowledge. And actually, I'm a corporate trainer before coming to here. I used to give training for who are having 10 years experience in the domain like artificial intelligence, data science, machine learning, and deep learning in cyber security. So there is an organization called Data Science Technologies at Hyderabad, Andhra Pradesh. So I used to give trainings for corporate trainings for TCS, Infosys, Google, various company people. They are taking training, and I'm giving training for them. And I'll ask you a small question. Within 60 seconds, what is happening in this internet world? Can anyone guess how many users are connected within 60 seconds? If you want to know with practicals, there is a URL I'm going to give you. You can find out number of users connected within 60 seconds. Can you imagine 3.8 million search queries within 60 seconds? 6,94,444 hours watched in the Netflix. 4.5 million videos viewed. Where I'm getting this sort of statistics? By using this URL, internetlivestats.com. So we come to know how many internet users in the world. Why I am showing? I'm searching for data. Where I'm getting data? Various sources. So these are the sources. And within 60 seconds, how many users are connected? Total number of websites, how many websites open? Very interesting question. We can see the number of users are connected through this internetlivestats.com. What is internet? Network of networks. What is network? Interconnection between the computers in the fashion of local area network, wide area network, metropolitan area network. www, World Wide Web. Who developed? Tim Berners-Lee. Who developed internet? Bold Bernard Newman. These are the IT jargons. We must know it, the terminology. So same thing I have incorporated in this presentation slide. Number of users are increasing automatically. Data centers of various organizations, they are increasing. So this is my syllabus and training program for data science. Today, I'll give you a glance of what is data science, how many subjects we are covering, what type of applications we can develop, how I can useful for GSER and CRC care. You can use me as if you want to analyze any data, if you want to generate any types of graphs, I'm going to help you to write program on your data. Recently, Maruf came to me. He has given 2 data sets. So within half an hour, I have given his results and analysis. So if you are having any data, so that I can do analysis, maybe classification, maybe clustering, association rule mining, outlier detection, any kind of data analysis, maybe regression analysis in statistics, in machine learning, in deep learning. There are various frameworks I'm going to explore right now with the practicals. So this is the syllabus, 13 subjects, core subjects of data science, uh, Python programming, anyone programming, not only Python. You can have familiarity in R programming. Why I have chosen Python? It is having n number of libraries, frameworks, packages. Comparatively, R, Java, it is having more number of packages. Some millions of packages are available. If you want to create your own package, yes, there is an option. We can create our own package for our data analysis purpose. Then probability and statistics, data structures and algorithms. Why do you want to study data structures? You have a data. We need to organize data, represent the data, access the data in the fashion of linear or non-linear. If you want to access linear, there are data structures algorithms like arrays, stacks, queues, linked list. If you want to access data in the fashion of non-linear, we have non-linear data structures like trees and graphs. Maybe this is computer science subjects. That's why you may not recognize this terminology, but you must know it. It is very important for analysis purpose and what type of technique you are applying for your data. Then database and data warehousing, then artificial intelligence, data mining. I'm extracting meaningful data from various sources by applying classification technique, clustering, association rule mining, outlier detection. Then NLP, natural language processing. I don't know Chinese, but I would like to talk. There are translators, study of different languages, study of linguistics, and that is called natural language processing. There are a number of applications are available. Then big data technologies. Which data I can call it as a big data? Can anyone? Which data I can call it as a big data? Terminology, measurements like computer understands only binary language. If you press capital A in the system, system can understand. And 0 or 1. Fantastic answer. System cannot understand if you type capital A in the system. Internally, it converts into ASCII format, American Standard Code for Information Interchange. Capital A value is 65. If you divide it by 2, you are getting binary equivalent number is 100001. That is binary equivalent of capital A. So the measuring of the data in terms of bits, bytes, kilobytes, megabytes, terabytes, petabytes, hexabytes, octabytes, yottabytes, zettabytes, protobytes, and geobytes. After that, infinity. This is the way we are measuring the huge volume of data, especially system, server, and data center. Data center, every company, every organization having their own data center. Data center and virtualization is the backbone for any MNC, multinational company. Data center is nothing but collection of high integrated servers at one place is called data center. Each organization having their own data center. So we have big data technologies like Hadoop, Spark, Python, or MATLAB. Various tools and processes are available in big data technologies if you want to handle in real-time environment. So then artificial neural networks, machine learning, deep learning, augmented reality, and virtual reality. This is the latest subject we have incorporated in the data science syllabus. Then coming to the various case studies. So far, I have done groundwater and climate change data analysis using AI, machine learning and deep learning techniques, and COVID-19 and variants of COVID-19, that is Omicron virus. How do we can detect and predict on chest X-ray images or CT scan images? I have done 10 papers and published in the SCI, Science Citation Index papers. Then Ebola virus prediction and detection, and chronic diseases like prostate, breast, skin, and lung cancer detection. These are the various case studies I'm going to demonstrate. So this is the terminology I have explained. See, if you see same terminology in mathematics, 1 kilobyte is 10 power 3, 1 megabyte is 10 power 6, 1 gigabyte is 10 power 9, 1 terabyte is 10 power 12, and big data range, if you see, 1 petabyte is 10 power 15, and exabyte is 10 power 18, zettabyte is 10 power 21, yottabyte is 10 power 24, brontobyte is 10 power 27, geobyte. Yesterday night, I searched in the Google, is there any terminology? Before going to bronto and geobyte, actually in India, one movie came called Robo. Before that Robo movie, we don't know the terminology. We haven't recognized the terminology like yottabyte and zettabytes. After seeing that movie, we came to know, oh, there is a measurement called, hi, I'm Robo. My speed is 1 terabytes and my memory is 1 zettabyte. Like that, they have introduced the terminology in that movie. Actually, it is there, but public doesn't know the terminology, huge volume of data, how do we measure? So there are two more terminologies presented called brontobyte and geobyte. 1024 yottabyte is equal to 1 brontobyte. 1024 brontobyte is equal to 1 geobyte. This is the way we are measuring the data. This is the syllabus of Introduction to Data Science. This is the syllabus of Python programming. With each topic, I'm going to demonstrate with practical, each topic. Okay, and so if you want to do more data analysis part, there are two parts in Python. One is core Python programming and advanced Python programming. If you go for advanced Python programming, if you know C, C++, Java, it is very easy to learn Python programming. If you don't know C, C++, Java, even though, if you know basic mathematics, that is enough to learn Python, very simple. And advanced Python programming like NumPy, numerical Python, scientific Python, pandas, scikit-learn, matplotlib, Theano, TensorFlow, Keras, PyTorch, and Pillow. There are various frameworks in order to solve statistical applications, machine learning related applications, and deep learning applications. We are using these advanced frameworks are called packages. So then statistics and probability, everybody knows. We have a descriptive statistics, probability, distribution, statistical inference, linear regression, nonlinear regression, logistic regression, and time series analysis, sampling methods, experimental design, etc. And this is the data structures and algorithm syllabus. And we have linear data structures, a systematic way of organizing data, representing data, and storing the data, and retrieving the data with the help of linear fashion and non-linear fashion. We have techniques like stacks, queues, linked list, trees. Those are the linear. Trees and graphs are non-linear data structures. And there are 4 approaches we are using in these data structures like divide and conquer approach, greedy approach, dynamic programming, branch and bound. How efficiently I can execute a program on a huge volume of data, whether it is taking 10 minutes or 5 minutes, how efficiently if you want to write program by using data structures and algorithms will help you. Then database management system, collection of interrelated data and storing of a huge volume of data in the System server and data center is called a data warehousing. So we have relational database tools, non-relational database tools. Relational database tools means based on the syntax, based on the relation, based on the table, we are creating the database is called a relational database. Languages like SQL, MySQL, Teradata, DB2, MS Access. These are the relational database tools. There are database like audio, video, text, graphics, animation kind of data is called unstructured data. How do you can handle with the help of non-relational database tools like Mongo database, Hive, HBase, Zookeeper, Woozy, Cassandra. These are the various tools are available in order to handle the unstructured data. So then artificial intelligence, intelligent behavior in a machine. We have a number of techniques we are using under artificial intelligence, including statistical techniques, machine learning techniques, deep learning techniques. Various techniques we are applying in order to extract insights, meaningful data, knowledgeable data from the big data sets. So this is the latest topic, generative AI. With this one, we are implementing intelligent applications. Intelligent kind of application if you want to develop. This is the latest topic right now in the industry. It is a advanced topic in artificial intelligence, especially generative adversarial networks. I'll give you a small example. In Japan, one of the scientists has developed one application called how 1 year baby look like, after 5 years, how it will look like, after 10 years, 50, over the period, how the facial expressions are changing. By using these GANs, generative adversarial networks, we can develop such type of applications. Likewise, various transformers are there, explainable AI, and we have generative AI, and transfer learning, deep learning, machine learning. These are the advanced topics in artificial intelligence. Then data mining. Data mining is the process of extracting meaningful data from the huge volume of data by applying classification, clustering, association rule mining. These are the approaches we are using in order to extract interested analytics from the huge volume of data. So in classification, we have a decision tree, random forest, k-means clustering, k nearest neighbor algorithm, support vector machine. Then clustering, I have explained already. How do you classify? How do you cluster the data based on the similarity measure? By using Euclidean distance, we can cluster the data. There are a number of algorithms. K means clustering, C means clustering, fuzzy C means clustering, etc. Association rule mining, it is one of the best technique in order to find the relationship between two items. In this scenario, I would like to give one small example. Han and Kumber, two persons have done research at in USA at Walmart. 10 years data they have collected from the Walmarts. What is the usually Saturday, Sunday outing with their children. So they used to go to Walmarts and collected some items, and then they are enjoying with their family. Like that, Han and Kumber collected the data from Walmart's 10 years legacy data they kept in the server. They have done a pre-processing techniques and extracted meaningful data from that 10 years data. Interestingly, they found two items are very heavily sold out. Can you imagine what are the two items are heavily sold out from the Walmart? Can anyone, any guess?
Water.
Water. Oh, you are closer, but not correct answer. Any guess? 10 years in Walmart data. Interestingly, two items are found with Coca-Cola. Not correct answer. She tried very good. Any answers?
Chocolate.
Calculate. See, I told you scenario. Employees usually they are outing with their children. They used to go to Walmart. They are purchasing something. But the two items are heavily sold out. What are the two items? Within 10 years duration. Very interesting. If you see the answer, you will surprise. Lollipop. Oh. It's okay. You are trying to reach answer, but not correct answer.
This is also data set.
Yes, yeah. So I'm giving answer. Any answer? Any guess? Toys. No. It is in the 90s, 1990 to 2000, they have done research. And the two interesting items are diaper and beer. See, how come by using this a priori algorithm and the frequent pattern growth algorithm, they found the two items are heavily sold out. Those two items are diaper and beer. So that is the speciality of association rule mining.
What's the relationship between Japa and
They have their own children. So that is hidden pattern extracted by this frequent pattern algorithm.
I think dads must be coming for shopping there.
So likewise, hidden patterns.
they drink more.
Here and maybe do the yeah. So then come to the natural language processing. I have explained study of different linguistics and different languages. By using these are the concepts we are doing research in natural language processing. Big data technologies. I told you one question. Which data I can call it as a big data? Any answer from your side? Which data I can call it as a big data?
Bigger than gigabyte or something you told?
Okay. No, you cannot justify
No,
like that.
Some software you said like Minitab and those things you said.
See, I have given some terminology, terabytes, petabytes, hexabytes, octabytes, what not. So I'm asking the simple question, my system unable to process such type of big data, then I can call it as it is a big data. My server unable to process and perform the application. So I can call it that data is called big data. Traditional systems are unable to process the data is called big data. We have big data technologies like Hadoop and Spark. Hadoop is a framework in order to process the big data sets like healthcare data, traffic data, weather forecasting data, maybe petabytes and hexabytes and octabytes data. And Spark is an extension of Hadoop. Spark is a streaming processing engine, means real-time audio, video, text, graphics, animation kind of data we can process. And whereas Hadoop can perform static data. It cannot perform on real-time data like audio, video, streaming data. Streaming data is nothing but flow of between one node to another node, one system to another system. Then artificial neural networks, this is the base subject for machine learning and deep learning. Okay, so machine learning from the observational data. There are three approaches. We have supervised learning and unsupervised learning and reinforcement learning. I think everybody knows you might have used regression analysis, statistical techniques under supervised learning. Under unsupervised learning, we have various algorithms like fuzzy C-means clustering, agglomerative clustering, K-means, dimensionality reduction, various kinds of applications we are developing, especially face recognition application. Comes under unsupervised learning. We are using principal component analysis technique. It comes under dimensionality reduction. Then reinforcement learning. Based on the punishment and reward, we are solving the applications, especially gaming applications. We have a number of algorithms like SARSA, PQN, DDPG, A3C, etc. Then deep learning from the observational data with a deep manner by increasing n number of input layers and hidden layers and we have activation functions, dropout, various parameters, hyperparameter tuning we are doing in order to increase the accuracy, precision, loss, and epochs, and we are reducing time complexity by using deep learning techniques. We have important and very popular techniques like convolutional neural networks, recurrent neural networks, and long short-term memory networks. These are the popular techniques nowadays, irrespective of domain. We can apply these classification and clustering techniques. Then augmented reality and virtual reality. Suppose your data is audio, video, text, graphics, animation kind of data. You can apply various deep learning frameworks like Keras, TensorFlow, PyTorch, Scikit-learn, etc. And these are the projects last 3 years at Bluecrest University. I'm heading the department, and there I have completed nearly 150 projects within 3 years duration. So among those 150 projects, these are like disaster response optimization, social welfare monitoring, and financial inclusion, agriculture and food security. And these are the various projects we have done. So these are the 150 projects. Recently, I have done one paper on this prediction and detection of groundwater data pollutants with the help of Professor Ravi sir and Alvin. I have done one or two papers. And this is what is the prerequisition of data science? Sir, I don't have prior knowledge in data science, but I am interested to learn data science. These are the prerequisition chart. You need to have knowledge on statistics, basic mathematics, any one programming language. In statistics, inferential statistics, and descriptive statistics. In mathematics, you might have studied linear algebra and calculus, and any one programming language. Excel, everybody knows. Then Python is so popular because of rich number of libraries are presented, and R is a visualization programming language. If you want to generate different types of graphs like a pie chart, bar chart, line chart, we can choose our programming language. Even in Python, we have a matplotlib library. If you install, we can generate n number of graphs. Depends on user requirement, we can generate. Then structured query language, that is a database language and relational language. This is my own chart. My experience, I have created this chart. You can start with the data. Data may be a raw material. Data may be audio, video, text, graphics, animation, any kind of. Then once we are processing the data is called information. Collection of interrelated data is called database. Collection of softwares. In order to manage the database, we have two types of languages, relational and non-relational databases. So combination of data, DBMS is called database system. And we are storing small amount of data in a system, server or a data center is called data mart. Data mart is called a sub-part of data warehousing. So collection of data marts and online analytical processing is called data warehousing. Once we are storing huge volume of data, what you are going to do? I'm going to extract interested analytics, insights, meaningful information by applying classification, clustering, association rule mining, outlier detection. And there are various tools that are also available in data mining like Veka, Rapid Miner. How many of you know Veka tool for data analysis we are doing? Waikato Environment Knowledge for Analysis. Veka came from Mecca. Mecca is a flyless bird at Waikato University, New Zealand. Two professors developed Veka tool for data analysis. Then big data deals with the big data sets like volume, velocity, and variety. What is the size of the data I'm handling? Is called volume. Megabytes, terabytes, petabytes, hexabytes, whatnot. Then volume. Then velocity, how speed you are downloading, uploading files, the speed at rate. Then variety, what kind of file you are handling, whether you are handling flat files, audio files, video files, etc. Can anyone give example for flat files?
It means what?
Yes. It is a industry term. Flat files, we are using Excel sheet, Microsoft Word, spreadsheet, etc. Fantastic answer. Then, then comes to the data science. It is the process of we are extracting insights by applying statistical, artificial, machine learning, and deep learning techniques to extract the meaningful, interested information. So, can anyone give what is this? By seeing this image, what is the technical name of this image? Can anyone guess what type of image? What is the name of the image? Yeah, fantastic. It is a word cloud. Yes. So word cloud is a terminology which integrates all sort of information integrated in that image. Is called a data word cloud. Everything. How do we can publicize about CRC care and GSER? By using pamphlets, by using WhatsApp, by using messages. Same way, this is one more way of publicizing any sort of image that is called word cloud. So, so data is a central for data science. Without data, there is no database application. So that's why there are various types of data we are handling in the real-time environment: categorical data, numerical data. And again, numerical data we can classify into discrete and continuous data. And how do you collect the data? There are various collection methods, tools. Through interviews, we are collecting the data. Through observation, we are collecting the data. Through surveys, we are collecting the data. Through focus group, we are collecting the data. Why do you want to collect the data? If you are having more data, it leads to the more knowledge. It leads to the more money. Why all MNCs like Google, Microsoft, and Apple, why they are using data science tools and techniques in order to increase their business? And that is the reason they are applying data science tools and techniques. Here, the caption of data science is, if you are having more data, it leads to the more knowledge, it leads to the more money. So these are the three important dimensions called characteristics. Like I have explained already, volume, the size of the data, and velocity, what type of data you are handling, real-time data, near-time data, or legacy data, old data. And data variety means what type of files we are handling, whether we are handling audio, video, text, graphics, animation, what kind of files we are handling in the real-time environment. So why should I learn data science? So in order to take better decisions, we are learning data science tools and techniques. So in order to, it is a problem of demand and supply. That's why we are learning. Every industry, every department, irrespective of a domain, you can learn data science and you can apply data science tools and techniques on your data. So, so there are three kinds of data: structured data, unstructured data, semi-structured data. So with the help of relational database tools, we are creating the data, and database is called structured data like SQL, MySQL, Teradata, DB2, MS Access, etc. Unstructured data means so audio, video, text, graphics. So that's why we are using Mongo database, Hive, HBase, Zookeeper, Woozy, Cassandra. These are the non-relational database tools. 50% XML and 50% structured and unstructured data is called semi-structured data. Now I am going to see, these are the very big MNCs. They are using data science tools and techniques like Amazon. Why they are using the data science tools and techniques? In order to increase their business. Okay, so even Facebook, Google, NASA, LinkedIn, Booking.com, Uber, etc. So the structure is, there are three tiers. Tier 1 data sources, We can feed the data structured and unstructured. And we can choose the technology like Hive, MapReduce, MATLAB, Hadoop. How many of you know MapReduce? MapReduce is one of the major concept component in Hadoop. So MapReduce is a programming engine where you are writing Java code and compilation and execution and get the results. Then finally, manager would like to see the results through dashboards, scorecards, through graph analysis like bar chart, pie chart, etc. So these are the different file formats we are having. So luckily, I'm working under the Professor Ravi sir and under G sir and CRCK. We are seeing different types of file formats. So here one among maybe audio, video, text, graphics, flat files, documents, books, transactions, etc. So these are the various tools like Python I have explained. I'm giving a glance on top 10 tools of data science. Python is so popular because of rich number of libraries are presented. R is a visualization programming and it is a competitor for Python for data analysis, for visualization purpose. Then SQL, then Hadoop, I have explained Hadoop is a framework in order to process the big data sets in big data technology. Spark is an extension of Hadoop, but the Spark handles the real-time data, means streaming data, audio, video, text, graphics. Tableau is one of the visualization tool in order to generate different types of graphs. Then Pandas is a framework in order to handle the data set. What is data set? Collection of rows and columns. So how many rows are there? How many columns are there? I would like to find out. You can use Pandas library. How to install in Python? I'm going to show you now practicals. Pip install Pandas. If you install, you can feed a large, a huge volume of data as a data set. It will classify how many rows are there, how many columns are there, average, standard deviation, every analysis we can perform under Pandas library, like TensorFlow. TensorFlow is a very big library out of some lakhs of libraries are present, some millions of libraries in Python. I'm using regularly TensorFlow. It is a 450 MB file. Once you have installed, you can do machine learning applications. Then Jupyter Notebook, it is a like editor. We have PyCharm, various kinds of editors. Then scikit-learn, that is called sklearn. It is also one of the framework in order to implement machine learning applications, even statistical applications. We can use scikit-learn.
Dr. Asadi, sorry to disturb. I think we'll have to take the questions now because only 10 minutes remaining.
Okay. Just 5 minutes. I'll demonstrate two things. So these are the top 10 algorithms of data science. Tools I have explained. See, these are the various tools are available in order to handle the big data sets. We have SAS, scientific analysis software, Apache Spark, MATLAB, Excel, Weka, NLTK, Tableau, Jupyter, etc. These are the top 10 softwares of data science. And these are the top 10 algorithms. Okay. So I'm closing theory part. These are the various applications of data science, image recognition, speech recognition. Wherever data is there, we can apply data science tools and techniques. See, Python is very big letters because it is dominating right now in the industry. Then R is there. See, why Amazon is using improving e-commerce experience. They are using data science tools and techniques. Why Uber is using data science, optimizing rides. Why Bank of America is using data science tools and techniques, increasing customer experience. Airbnb, improving searches, etc. So these are the techniques are available. I'm closing this theory part. These are the top 10 algorithms I have executed. The first application, linear regression. See, now I'm going to demonstrate a small application. See here. So if you don't have Python, no problem. So if you once installed, it is a 23 MB file. Just go to Google, type Python software, you will get it. You can double click. It will take 2 minutes for installation. Once installed, you can check like Python whether it is installed or not. Yes. So you can execute small application like addition of two numbers. Very simple. See, if you know basic mathematics, you can execute applications like simple application. Python can be executed in two ways. One is scripting way, and another way is command line argument. You can call it as a command line. Now this is called two ways of execution, same file. See, suppose a linear regression, I would like to open the file. I have already executed a linear regression. See, this is the program. Write a Python program for linear regression to predict students' marks within hours. Suppose, say I imported necessary libraries like NumPy and Matplotlib. Suppose a student studying 2 hours is getting 60 marks, x-axis and y-axis. 3 hours if he study, he is getting 70 marks. So now I'm executing that program. Python space linear regression. See, I'm generating linear regression. If a student studies 2 hours, he is getting 60 marks. 3 hours, 70 marks. Likewise, we can generate linear regression. Same application, if I want to see non-linear fashion, see this program I have executed. Now same program, non-linear regression to predict student marks within hours, same. So by using that formula, uh, polynomial function, we are performing this x-axis and y-axis, and we are executing that program. So this is the program. So same, we are importing NumPy, SciPy, defining the polynomial function, defining the input and output variables, x-axis data, y-axis data, and estimate the coefficient. So now I'm executing. Same way, I can execute one more program, logistic regression. See, if student gets 1 means pass, and a student get 0 means fail. Same exact. X-axis and y-axis, I'm taking the data, and I'm creating and fit linear regression model, predict test scores by new data. So logistic regression, I'm executing. So Python space.
Dr. Asadi,
Yeah, I'm
mindful-
closing.
Yeah, maybe we
Yeah,
go.
we all know how to run this.
Oh, sorry.
You don't need to run it fast.
Okay.
Questions?
Okay, sorry.
Yeah, my first question is.
Yeah, please.
Your data science,
Yeah.
I believe that majority of your work related to society.
Yes.
Societies. So, as you mentioned that Walmart's, you're getting data from the supermarkets to do the study, find a relationship with idea with napkins. Okay, my question is, how do you get this data? Like, are they this supermarket give you the data, or you can purchase from them, or so this sort of relating to the data security or privacy.
Yeah.
So how do you handle this privacy?
See, it is a very tricky question. In order to get data from government of Australia, it's very tough. So that's why there are 3 websites are available. You can have synthetic data or some standard data sets are available. One URL you can download from a website www.uci repository, and one more repository is Kaggle, www.kaggle.com, and one more repository called GitHub. From these 3 repositories, you can download various data sets freely available. But if he is asking the questions, societal related data, I cannot get without permission of Australian government. It's very tough. Even in India, we have a green card like Aadhaar card. We cannot get that data as it is. We need to take permission from the government of India. Then only we can get the data. Once we have data, then we can do many things. We can play with it.
In my case, I have very small number of data.
Yeah.
For an example, very difficult to generate thousands of data in the lab by experimental data.
Yes.
So I have maybe 6-10 data and maximum 50 to 100.
Okay.
So within this small number of data, how I can play,
Okay.
how I can apply, how I can
Generate more number of
More.
records. Yes, there is a function I will explain to you.
and
You give me your data. If you want to double, triple the data, there are some ways I will explain to you.
and utilizing this maybe hundreds of data, how I can
Small
make,
program you need to write to generate synthetic data. We have real-time data, synthetic data.
and
Yes.
how we can make relationship with
Yeah, that
one
there are.
parameter, another parameter.
So we
How
can
can-
go for MLP, like multi-level regression analysis.
Regression
Yeah.
analysis. And
That
how
we can apply.
Okay.
We have linear
Clusters.
regression, non-linear regression, logistic regression.
Sorry to disturb,
Yeah.
a very good discussion. We have another meeting here. So thank you very much, Dr. Asadi, for your great presentation, and thank you everyone for your inputs and questions.
Thank you. very much.
Yeah, thank you very much. And have something before you give.
Son, my son.
Please have something before you.
Hey, you forget to tell that. That is important. Come on. I give.